Hi, my name is Jean-Jacques Dubray, and I would like to give you a quick introduction about the SAM pattern. Just to set the context, the SAM pattern is a new pattern that helps you build modern uh, user experiences that include friends, players, wearables, IoT sensors. It's able to process network events as well as user events in a new kind of programming model. So the way we build building front-end architectures has not changed that much over the last 30 years. It's always based on events and callbacks. Um, that kind of code has quite a few issues with it. The first one is it's hard to extract components that you can reuse across applications or even tasks and scenarios within the same application. It has a poor encapsulation. It often relies on global variables. It requires manual subscriptions of the events. It has a poor separation of concern where direct DOM manipulation is often part of the event handler itself. And more recently, it has started to have data consistency issues as network events become prevalent. Of course, JavaScript is single-threaded, but the processing of those events can be concurrent, and therefore, as you update the model, subtle problems, subtle bugs can start appearing. Overall, this code is hard to maintain, debug, or hand off if somebody leaves the team and new developers need to learn the code. So I created the SAM pattern about 6 months ago in January this year. And the first principle of the pattern is that it's based on functional HTML. React showed the way. It told us, the view can be expressed as a function, a pure function of the model. This is the future. This is where things will be going. Now, the industry is kind of struggling to go the other way, to factor the business logic within a event handler. And that's kind of where SAM comes in. At the moment, the cool kid is functional reactive programming. There's a number of frameworks and such as Elm and Cycle.js that are attempting to provide a pure FRP view of the world. SAM is taking a 180-degree turn. It's about not ignoring, not hiding application state mutation, but it's about making application state mutation a first-class citizen of the programming model. So let's see how we can do that. So SAM is based on a formalism, one of the most robust formalism of computer science called TLA+. It was created by Dr. Lamport, a researcher at Microsoft. But at the end of the day, SAM is really, really simple. So let's take an example. We have the simplest model possible, a counter, and each time an event is produced, the counter will increment. So most people now would write the mutation of the application state as counter equal counter plus 1. In reality, this is not exactly how things look like. If we go back to TLA plus, the first thing you need to do is to create a proposal. The proposal is, of course, counter plus 1. This is the value eventually you want the counter to take. But you cannot just yet assign that value to the counter. What you need to do is, as a critical section, you need to request the model to accept the proposed value. And then, only then, you can access the new application state when the proposal has been accepted or rejected. Of course, the proposal can be much more complex than a single value. But then, when it's been accepted or rejected, then you can, quote, involve a learner, that will access the application state and do something about it. So with SAM, actions are proposers, models are acceptors, and the state function, which is somewhat of a new concept that's not very common in modern framework, is a learner. And this terminology, proposer, acceptor, and learner, is coming from Paxos, the Paxos protocol, that was also created by Dr. Lamport. and that's pretty much it. What you're looking at is SAM. SAM is a simple way of factoring your business logic, a way that is focused on application state mutation. So let's look at an example. This is a little fishing game. You can find the code on GitHub. It's you're drawing a rectangle. There's a number of hidden fishes, and once you finish drawing the rectangle, the application will count how many fishes you caught within that rectangle. So the first piece of code is an action. The action translates the event into a proposal, and here we'll translate the position of the mouse down event into a new rectangle request to the model. As a unit of work, the model will accept that new request, and we'll do a number of initialization. As you can see, the last property value is a selected fishes, which is completely unknown to the action, and it shouldn't be known to the action. And that's kind of the healthy divide between proposals and proposers and acceptors, is the model has full access to all property values when the proposer only focuses on translating the intent of the user into a proposal that can be understood by the model. The next step in the pattern is the learner. It's a state function. So the state function creates the state representation, which will be displayed by the view. And often the view will use a theme of components to render that state representation. So it will just pass different parts of the state representation, here the rectangle, to a theme component, and a theme component will draw the rectangle. The last step is what's called the next action. So given an application state, there could be some business logic that needs to be executed. Here, if we are in the state of counting objects, we will want, which means we just receive a mouse up event, and what we would want to do is initiate the action of selecting the objects. And at that point, the object will be counted, and a new reactive loop will be started with a new representation that will display how many fishes were caught. So that's SAM. SAM can be summarized in one line of code where the view is a function of the model. That function is called state, and the model is updated with a proposal from an action. And then once the state function has rendered the application state, it also computes the next action predicate and execute any action if needed. I want to emphasize that SAM is very simple. This is what Daniel Neveu, a entrepreneur and full stack developer, told us about the pattern when it started using it. It's simple. It's a very minimalist concept, but at the same time, it's very, very powerful. And I'll certainly second that. So in conclusion, the programming model is focused on mutation. It includes a single state tree, and that's a true single state tree. There is no other application state than in the model. It's also focused on what's allowed, what are the actions that are allowed rather than subscription. The view components are 100% decoupled from the application logic. That's a big benefit. It's based on functional HTML, which is somewhat of a form of code generation compared to template, which are more interpreted. And SAM can be implemented with any web framework, Angular 2, React, Vanilla.js. There are examples on GitHub with pretty much all the popular frameworks. The wiring, SAM is agnostic to any form of wiring. I would recommend that you be skeptical of programming models that are focused on wiring. I don't think it's a healthy architecture. From an architecture perspective, SAM is side effects friendly because of its roots in TLA plus and mutation. It implements new concepts such as action hangback and generate cancellations. It also allows you to write business logic that is truly isomorphic. I've shown over and over that the code of the action, the model, and the view and the state can be migrated to the server at any point in time. And it also supports third-party actions that would present proposals to the model say using an OAuth protocol with an OAuth token. That's it. If you have any question, feel free to go to the homepage at sam.js.org and or join us on Gitter, and a lot of people would be happy to answer your question. Thank you.